All right, today we're going to crack open one of the most powerful technologies out there, machine learning. We're going to break down the two main steps that let machines learn and, maybe more importantly, predict what's going to happen next.
I mean, it's a question humans have been asking forever, right? We look at the clouds to guess if it'll rain. We watch the market to predict stocks. But what if there was a way to make that process, a little more systematic?
And that's really the fundamental idea. Machine learning isn't using some kind of crystal ball, nope. It uses data. It learns from all the stuff that's already happened to make a really good, educated guess about what's coming. Okay, so let's get a bit more specific here. When you strip away all the hype, what is machine learning really? Think of it as a team up. You've got data scientists who are like detectives finding all the hidden patterns in the data. And then you have software engineers, the builders, who take that intelligence and weave it into the apps we use every day. It's this process that turns raw info into a tool that can actually do something useful. And you see it everywhere. An ice cream shop owner, they could use it to figure out how much ice cream to make based on the weather forecast. A doctor could use it to spot a patient who's at high risk for diabetes way earlier. Or a scientist could use it to automatically figure out which species of penguin they're looking at. It's all about turning data into actual decisions. Now, to really get how this all works, we need to learn a couple of key terms. Think of it as the basic vocabulary for speaking the language of machine learning. So, it all starts with two key ingredients. First up, we have features. Just think of these as your inputs, the data you already have, like the temperature or if it's raining. In the machine learning world, we usually just call these X. Then we have the label. This is the answer you're trying to figure out, like how many ice creams were sold, and we call this Y. So the features are your question, and the label is the answer you already have from the past. And what's really cool is you can see how this simple pattern applies to totally different problems. For that ice cream shop, the features are the weather. The label is sales. In a clinic, features could be a patient's weight and blood sugar, and the label is their diabetes risk, a simple 0 for no or 1 for yes. For scientists in Antarctica, features might be a penguin's flipper length, and the label is its species, maybe represented by a 0, 1, or 2. See? It's the same fundamental idea, just pointed at different questions. Now that we've got our ingredients, we're ready for the first big phase, training. This is where the learning part of machine learning actually happens. And the goal? It's all about finding a secret recipe that's hidden in the data. The entire point here is to look at all that old data, all those X's and the Y's that went with them, and figure out the mathematical rule that connects them. Like, how exactly does the temperature affect ice cream sales? That relationship, that pattern, that's what we're hunting for. And the process is pretty straightforward when you break it down. You start with your past data, the features and the labels. You feed all of that into a learning algorithm. That algorithm just crunches the numbers until it discovers the hidden pattern, that recipe we were talking about. And finally, that recipe gets saved as a model, a little piece of software that's now ready to make some predictions. And here it is. This is the secret recipe. All of that complex training boils down to this simple but incredibly powerful function. F is basically the math formula the model learned. It's the rule that takes your features, your X, and uses them to calculate the label, Y. This little equation is the whole prize from the training phase. So we have our model, we found the recipe. Now what? Well, now we move to phase 2, inferencing. This is where we put our model to the test in the real world. And the difference between these two phases is super important. During training, you use both the features and the known answers to build the model. But during inferencing, you only have new features that the model has never seen before. You feed those new features in, and what pops out the other side is a prediction. So inferencing is really where the magic happens. It's that moment you take all the wisdom the model learned from the past and you apply it to a brand new situation to predict what's going to happen. It's all about forecasting. And the output, that prediction, it gets a special name. It's not Y, because Y is a fact from the past. It's Y hat, and you pronounce it Y hat, which is kind of fun. That little hat on top is just our way of saying, hey, this is an educated guess from our model, not something we've actually observed. All right, let's bring this all back home. Let's see how we go from just a bunch of data to a real, concrete decision that we can actually use. Okay, so imagine we're back at the ice cream shop. Training is done, we have our model. Now we check tomorrow's weather forecast. It's going to be sunny, it's going to be warm. These are our new features, our new X's that the model hasn't seen before, and we feed them right into the model. And boom, out comes our prediction. Our YAT, the model uses that secret recipe it learned from all the past data, and it forecasts that the shop is going to sell 275 ice creams. And that's not just a random guess. It's a data-driven prediction. It gives the owner a real number they can use to prepare for the day.
And really, that's the whole process in a nutshell. You train on the past to find a pattern and create a model. Then, you use that model for inferencing on new data to predict the future. It's this powerful two-step dance. So, if this same basic idea can be used to predict ice cream sales, or help diagnose diseases, or classify animals, it kind of makes you wonder, what are the limits? What other huge, complex questions are we just one good data set away from answering?